Welcome back to our Math 171 video series. For these videos, we'll talk about how to deal with complex numbers and what they mean. In this problem, we are to simplify the expression square root negative 108 plus square root 72 minus square root of 8. Notice that our first term has a negative inside the square root. If you see one of those, you can be assured that this will be a complex number. Notice that's different from our last term, which has a negative outside of the square root. That negative square root of 8 is not complex. In order to simplify complex numbers, we begin by trying to split these square roots into their components. We'll use the rules of perfect squares in order to break these square roots up into something we can simplify. We'll begin with the square root of negative 108. Now, when you have a negative inside of the square root, the first thing that we'll do is split the negative 108 into negative 1 and positive 108. This will move the negative away from the 108 to where we can work with the 108 more easily. We'll now change this to say square root 108 times square root negative 1. Now let's try to think of some numbers that will divide the 108 evenly but are perfect squares. Now you may notice that 108 is divisible by 4. 108 divided by 4 will give us 27. So we can rewrite the 108 as square root 4, square root 27, and now also square root negative 1. However, that 27 is divisible by another perfect square, 9. 27 divided by 9 will give us 3. So now we have square root 4, square root 9, square root 3, square root negative 1. Square root of 4 is just 2. Square root of 9 is just 3. Square root of 3 cannot be simplified any further. And then square root of negative 1, we give the special letter I. This is how we abbreviate square root negative 1 when we're dealing with complex numbers. So when we rewrite this square root negative 108, we take 2 times 3 times I and multiply them all together. So this is 6I square root 3, and we'll replace our first term with that. Let's also try to simplify the square root 72 the same way. There's no negative inside, so this will have no I. If we take 72 and try to divide it by a perfect square, you might notice that this is divisible by 36. 72 over 36 will give us 2, and so square root 72 will be square root 36 square root 2. This is the same as 6 root 2. Notice again, this does not have an I. We'll just say this is 6 square root 2. We'll do the same thing with 8. Notice the negative is not inside, so this will also have no I. Now, 8 is divisible by the perfect square 4. 8 divided by 4 will give us 2, and so this is square root 4 square root 2. However, square root 4 is just 2, and so we'll have 2 square root 2. Now let's combine together what we can using these terms. Now, any terms that have the same square root and the same letters, we can combine. Let's have a look at our roots first. Our first term has square root 3, and our other terms both have square root of 2. This means the term that has the square root 3 cannot combine with the terms that have square root 2. Also, that square root 3 term contains an I, and I terms cannot combine with non-I terms. The terms that contain I are called imaginary. The terms that do not contain I are called real. We do not combine real terms with imaginary terms, but we can combine real terms with each other as long as they have the same root. Similarly, imaginary terms can combine with each other as long as they both have I and the same root. For that reason, we can combine the real terms together because they both have square root 2. We have 6 and negative 2, and 6 minus 2 gives us positive 4. Therefore, we'll combine the real terms together and get 4 root 2. The imaginary term stays the same because we have nothing to combine it with, and we'll have 6i root 3 for that. This will be the simplified form of the expression we started with. We have simplified the square roots and combined them, and found which terms contain I and which don't.